this stage of the project, our students have started their technical activity. Some of them are focusing on algorithmic aspects, others are focusing on the hardware measurement, some others on mathematical modeling of federated learning. And I would say this is the perfect timing for them to get this training here oriented toward machine learning, distributed computing, distributed learning. I believe this will boost their productivity towards a new breed of algorithms and paradigms for sustainable edge computers.
For the moment, we are measuring energy consumption of different edge computers and devices that we have at our labs based on different applications and machine learning algorithms that we run on them. After getting these data, we will model the energy consumption of the edge computers based on their workload versus their applications. This model will be the baseline for our future research. We want to design optimization algorithms to schedule the network resources, and this energy model that we want to extract right now will be the first starting point for our future research.
I am working in water sensing, and we are developing some hardware and software in order to monitor civil and critical infrastructures. And so in order to do that, we are developing a protocol which allows us to synchronize really far-edge devices, and then we want to process information inside those devices in order to achieve really monitoring systems as efficient as possible. And we are really confident that through the use of machine learning and artificial intelligence, we will get to that position.
I'm working on developing a framework for the anomaly detection and energy consumption of IoT technologies, and I'm currently working with Bluetooth Low Energy, which is a commonly used technology for the Internet of Things. And I'm building a data set on the energy consumption of BLE nodes, and we will then also manually insert the anomalies and detect them via highly accurate machine learning algorithms like LSTMs.
At this moment, we have selected the system-on-chip based boards to design our light IoT first node. Basically, this node is expected to be battery-free, so we are using supercapacitors, and also the idea of having sustainable solution brings us to use printed electronic components, and we also gonna work with a printed energy harvesting unit on solar cells.
What we are doing here in this Greenedge project, the concept of light-based IoT, in which we will implement using printed electronics some IoT nodes. So the nodes will be energy autonomous. All the energy is harvested from the light, and they will be printed partially on printed electronics and partially using conventional electronics. And the light will also be used to send and receive data. So this is, as I said, an initial step towards something bigger that we call living surfaces, like we will have on our walls, ceilings, even small surfaces, everything printed there.